Welcome to Ancient Relics Keeper, where lost truths, ancient mysteries, and forbidden history collide. Let's question the past and uncover what was never meant to be found. In 1976, a NASA lander conducted an experiment on Mars. The result was positive for life, then officially dismissed as a chemical error. For nearly 50 years, that initial result has remained one of space exploration's most persistent, unanswered questions. In the summer of 1976, two identical spacecraft, the culmination of a decade of work and immense national investment, descended through the thin, pink sky of Mars. They were the Viking landers, the most sophisticated robotic explorers ever built. Their primary mission was audacious, a goal that had captivated humanity for centuries: to answer once and for all if we are alone in the universe. On board each lander was a miniature, automated biological laboratory designed to perform a series of experiments on the Martian soil. One of these experiments sent back a result that was clear, repeatable, and consistent with the presence of life. That result was then officially rejected, a decision that created a scientific paradox that has persisted for nearly half a century. This is the story of that first ambiguous contact, a story of a positive signal from a dead planet. The Viking program was born from an era of scientific whiplash. In the early 20th century, Mars was a world of popular imagination, fueled by astronomers like Percival Lowell, who claimed to see vast, engineered canals crisscrossing its surface, evidence of an intelligent, dying civilization. This romantic vision was shattered in the 1960s by NASA's Mariner flyby missions. The first grainy images they returned showed not a world of canals and cities, but a surface that looked disturbingly like the moon. Cold, cratered, and seemingly lifeless. The atmosphere was revealed to be incredibly thin and composed mostly of carbon dioxide. The dream of a living Mars appeared to die with those first photographs. Yet some scientists were not convinced. The Mariner missions were just fleeting glimpses. They argued that while complex life might be absent, microbial life could still exist, dormant in the soil, waiting for the right conditions. This possibility was too profound to ignore. And so the Viking program was conceived with a clear historic mandate: land on the surface and actively search for life. To accomplish this, NASA designed a suite of 3 different biology experiments, each based on a different assumption about what Martian life might be like. The idea was to create a system of checks and balances. A positive result from one experiment would be far more convincing if it was supported by another. The centerpiece of this effort was a complex instrument package that occupied a significant portion of the lander's body. A robotic arm would scoop up a sample of the reddish soil and deliver it into a distribution system that would funnel it into tiny test chambers for analysis. Of the 3 experiments, one was uniquely direct in its approach. It was called the Labeled Release Experiment, or LR. It was the brainchild of an engineer and scientist named Dr. Gilbert Levin. The concept behind it was simple and elegant, based on a fundamental characteristic of nearly all life on Earth: metabolism. Living things consume nutrients and release waste products. The LR experiment was designed to detect this process. The procedure was straightforward. The Martian soil sample would be placed in a small test cell. Then, a drop of liquid nutrient solution would be added. This solution was a cocktail of simple organic compounds, a kind of chicken soup for microbes. Crucially, the carbon atoms within these nutrients were labeled. They were a radioactive isotope, carbon-14. The theory was that if there were any living microorganisms in the soil, they would consume the nutrients. As they metabolized this meal, they would release gas just as we exhale carbon dioxide. Because the carbon in their food was radioactive, the gas they released would also be radioactive. A sensitive radiation detector was positioned above the sample, ready to count any radioactive particles that appeared in the atmosphere of the test chamber. The experiment was designed with clear expectations for both a positive and a negative result. If the soil was sterile, nothing would happen. The nutrient broth would sit there, and the radiation counter would remain silent. If life was present, however, a very specific signal was expected. A steady, sustained release of radioactive gas as the organisms consumed their meal. The graph of the results would show a distinct curve, rising quickly at first, and then leveling off as the food supply was used up. To be certain that any detected reaction was biological, the experiment included a critical control. After the first test, a second identical soil sample would be heated to 160 degrees Celsius, a temperature high enough to sterilize it and kill any potential microbes. The same nutrient solution would then be added. If the first reaction was truly biological, this second sterilized sample should produce no reaction at all. The control would remain flat. On July 28, 1976, 8 days after Viking 1 made its historic landing on the plains of Planitia, the command was sent from the Jet Propulsion Laboratory in California to initiate the first labeled release experiment. The robotic arm extended, dug its scoop into the rusty soil, and delivered the sample. The nutrient solution was injected. On Earth, scientists, including a deeply anxious Gilbert Levin, watched their monitors as the data began to stream back across more than 200 million miles of space. Almost immediately, the radiation counter began to register counts. Gas was being released from the soil. The numbers climbed steadily, minute by minute. The data points formed a curve on the graph, and it was a curve that looked stunningly familiar. It was a near-perfect match for the positive result curves they had generated in countless pre-flight tests using microbe-laden soils on Earth. The initial excitement in the control room was palpable. It appeared NASA had found evidence of life on Mars on its very first try. The experiment continued for several days, the curve eventually leveling off exactly as predicted by a biological model. Then came the control test. The second sample was heated, sterilized, and then fed the same nutrient solution. The result was exactly what the biological hypothesis required. The radiation counter remained virtually silent. The reaction that had been so vigorous in the first sample was now gone. The sterilization process had stopped it. To the LR team, this was a powerful confirmation. They had a positive result and they had a successful control. The case for life grew even stronger a few weeks later. On September 3, 1976, the Viking 2 lander touched down thousands of miles away from Viking 1, in a region called Utopia Planitia. It carried an identical set of experiments. When its LR experiment was run, it returned the same result. A rapid release of radioactive gas that was halted when the soil was sterilized. The phenomenon was not a fluke unique to one location. It was present at 2 distant sites on the planet. For Gilbert Levin and his team, the conclusion seemed unavoidable. "We had a positive detection of life on Mars," he would later state. The data fit every pre-mission criterion established for a positive result. However, this initial optimism was about to collide with a profound scientific contradiction, delivered by another instrument on the Viking lander. While the biology experiments were looking for the activity of life, its breath, so to speak, a different instrument was designed to look for its body. This was the gas chromatograph mass spectrometer, or GCMS. It was a sophisticated device designed to detect and identify organic molecules in the soil. Organic molecules are the carbon-based compounds that form the essential building blocks of all known life, things like amino acids, proteins, and lipids. The presence of life, living or dead, should leave behind a detectable signature of these molecules. The GCMS was considered by many mission scientists to be the ultimate arbiter. The GCMS heated the Martian soil to high temperatures to vaporize any organic compounds present, then analyzed the resulting gases. The scientific community waited for its findings, expecting it to confirm the LR results with the rich inventory of Martian organics. The result that came back was a shock. The GCMS found nothing. No amino acids. No complex hydrocarbons. No trace of the building blocks of life. The Martian soil, according to the GCMS, was completely devoid of organic matter. down to a sensitivity of parts per billion. This created an immediate and irreconcilable paradox. How could something be metabolizing if it had no body? The labeled release experiment was detecting the breath of life, but the gas chromatograph mass spectrometer could find no evidence of a breather. It was a direct, head-on collision between two different high-tech instruments. One had to be wrong. The scientific community, faced with these conflicting results, had to choose which to believe. The prevailing consensus quickly fell on the side of the GCMS. The absence of organic molecules was seen as the more definitive piece of evidence. The assumption was that if there were no organics, there could be no life. Therefore, the positive signal from the labeled release experiment must have been caused by something else, not biology, but some strange exotic chemistry in the Martian soil. Scientists began to propose non-biological explanations. The leading theory centered on the idea that the Martian surface is saturated with highly reactive, non-biological oxidants, such as hydrogen peroxide or superoxides. These are potent chemicals created by the interaction of ultraviolet radiation from the sun with minerals in the soil, in the absence of a protective ozone layer. The hypothesis was that when the LR experiment's liquid nutrient solution, which was water-based and contained simple organic compounds, was added to this highly reactive soil, a purely chemical reaction occurred. These oxidants could have aggressively broken down the organic molecules in the nutrient broth, releasing the radioactive carbon gas and perfectly mimicking the signal of life. This chemical explanation also seemed to account for the successful control experiment. Heating the soil to 160 degrees Celsius could have been just enough to break down these unstable chemical oxidants, rendering the sterilized sample inert. While this explanation was never definitively proven, it was plausible enough to resolve the paradox for most scientists. The official conclusion of the Viking mission was announced. The landers had found no conclusive evidence of life. Instead, they had discovered a strange self-sterilizing chemistry on the surface of Mars. The planet was declared dead. This conclusion shaped the course of Martian exploration for decades. The search for life was effectively abandoned, replaced by a new mantra: follow the water. But for Gilbert Levin and a small number of supporters, the case was never closed. He has spent the subsequent decades arguing that his experiment was right all along, and that it was the dismissal that was the error. He points to several critical flaws in the chemical explanation. First, later analysis showed that the GCMS on Viking was not as sensitive as once thought. Tests on Earth demonstrated that it would have failed to detect organic molecules in Antarctic soil samples that were known to contain living microbes. The absence of evidence, he argued, was not evidence of absence. Furthermore, the chemical oxidant theory struggled to explain why the reaction occurred at two different sites with different temperatures and conditions, and why it behaved so consistently like a biological process. Over the years, Levin has reanalyzed the Viking LR data, publishing papers that show it exhibits a circadian rhythm, a pattern consistent with life, which is difficult to explain with simple chemistry. For nearly 50 years, the Viking lander paradox has remained. It stands as a profound scientific puzzle. We received a signal from another world that met all the predefined criteria for life. That signal was repeatable across thousands of miles. It was nullified by a control experiment exactly as expected. Yet, because another instrument failed to find the evidence it was looking for, the initial result was set aside. The official story became one of unusual chemistry. But the question lingers, a quiet but persistent whisper from that first contact. What if the simplest explanation was the correct one? What if the experiment designed to find life actually found it, and we were simply not ready to believe the answer it gave us? Following the controversial outcome of the Viking missions, the official search for life on Mars came to a halt. The scientific consensus had settled. Mars was a sterile planet with an exotic, oxidizing chemistry. For 2 decades, robotic exploration of the red planet went quiet. The direct, ambitious approach of looking for life had yielded only ambiguity. When NASA was finally ready to return, it was with a fundamentally different, more cautious strategy. The new directive was not to find life, but to find the single most important prerequisite for it. The new mantra, which would define the next generation of exploration, was simple: follow the water. This shift in focus represented a strategic retreat to a more defensible scientific position. Instead of asking the complex question, is there life on Mars? Scientists began with a simpler, more foundational one. Was Mars ever a place where life could have existed? Answering this required a different kind of explorer. Not a biologist in a box, but a geologist on wheels. In 2003, NASA launched a pair of robotic geologists, the Mars exploration rovers named Spirit and Opportunity. They were twin rovers, far more mobile and durable than the stationary Viking landers, designed to travel across the Martian landscape for months, reading the story written in its rocks. Their mission was to hunt for evidence of past water activity. This could take many forms: minerals that only form in the presence of water, rock layers deposited by ancient seas, or the eroded remnants of shorelines and riverbeds. Spirit was sent to Gusev Crater, a vast basin that appeared from orbit to have been an ancient lakebed. Opportunity was targeted to a flat, smooth plain on the opposite side of the planet called Meridiani Planum, chosen because orbiting instruments had detected a strong signature of a specific iron-bearing mineral called gray hematite. On Earth, hematite often forms in water. Opportunity's job was to land and find out if the Martian version did too. On January 25, 2004, Opportunity successfully landed inside a small crater. A stroke of luck that immediately exposed ancient rock outcrops. Almost as soon as it began to analyze its surroundings, it found exactly what it was looking for. The bedrock was full of tiny spherical pebbles that scientists nicknamed blueberries. These were hematite-rich concretions, almost identical to those that form on Earth when minerals precipitate out of water seeping through rock. This was the first piece of ground truth evidence. But the rover soon found a much more definitive clue. Using the instruments on its robotic arm, Opportunity analyzed the chemical composition of the outcrop rocks. It discovered they were rich in sulfate salts. More importantly, it detected a specific mineral called jarosite. This was the smoking gun. Jarosite is a hydrated potassium iron sulfate mineral that, on Earth, absolutely requires the presence of acidic water to form. There was no plausible way for it to exist in such quantities without a significant history of liquid water. Opportunity wasn't just looking at a place that was once damp. It was sitting on the shoreline of what was once an ancient salty sea. Over the course of its astonishingly long mission, which lasted nearly 15 years, Opportunity would travel across miles of these plains, finding the same evidence everywhere. It had proven that this region of Mars was once submerged. Meanwhile, on the other side of the planet, Spirit was having a more difficult time. Gusev Crater, expected to be a lakebed, was covered in volcanic basalt. For months, it found little evidence of water. But as it traveled and climbed into a range of hills, its fortunes changed. There, it discovered rocks incredibly rich in pure silica. On Earth, concentrated silica deposits like this are a hallmark of hydrothermal environment, hot springs or volcanic vents, places where hot, mineral-rich water has circulated. This was a critical discovery. It showed that Mars not only had surface seas, but also had diverse aquatic environments, including the kind of energy-rich hydrothermal systems that many scientists believe are a prime location for the origin of life. Together, Spirit and Opportunity transformed our understanding of Mars. They systematically dismantled the image left by the early Mariner flybys of a perpetually cold, dry, moon-like world. They replaced it with a detailed portrait of a planet with a dynamic, wet past. Mars billions of years ago was a world with surface water, with seas and lakes, and with hot springs. It was, by all scientific definitions, a habitable planet. This success led directly to the next, even more ambitious mission. With the question of a habitable past settled, NASA launched the Mars Science Laboratory, a rover named Curiosity, in 2011. It was a mobile laboratory the size of a small car, sent to Gale Crater. Its target was Mount Sharp, a 3-mile-high mountain of layered sedimentary rock, rising from the crater floor. This mountain was effectively a history book. By driving up its slopes, Curiosity could read the rock layers and analyze the changing environments of Mars over millions of years. Curiosity's findings were even more profound than those of its predecessors. Soon after landing, it drove across what was unmistakably an ancient streambed, complete with rounded pebbles smoothed by flowing water. When it reached the base of Mount Sharp, it drilled into fine-grained rock layers. The analysis revealed these rocks to be mudstone, a type of rock that forms from fine silt settling at the bottom of a calm, standing body of wet-era lake. Critically, the chemistry of this ancient lake was different from the acidic sea Opportunity had found. The water in Gale Crater's lake was likely freshwater, with a neutral pH, low in salinity, and containing key chemical elements necessary for life. It was an environment that would have been remarkably comfortable for microbial life as we know it. This series of discoveries, from the blueberries found by Opportunity to the freshwater lakebed confirmed by Curiosity, created an entirely new picture of ancient Mars. The planet was undeniably once habitable, but this triumph of geological exploration had a strange and unsettling consequence. It made the original Viking paradox even deeper. The core of the problem was now this: we had proven that Mars had long-lasting, stable bodies of liquid water. On Earth, anywhere you find a history of water, you also find a rich inventory of organic molecules. Organics rain down constantly from space via meteorites. They are created by geological processes. And, most importantly, they are the building blocks and byproducts of life. A planet like early Mars, with its thick atmosphere and abundant water, should have had organic compounds preserved in its soil. This made the result from the Viking GCM-6's complete failure to find any organic molecules all the more baffling. It was no longer just a contradiction with the labeled release experiment's positive signal. It was now a contradiction with the entire geological history of the planet that Spirit, Opportunity, and Curiosity had so painstakingly uncovered. Why would a planet that was once warm, wet, and habitable have soil that was apparently more sterile of organic material than soil from the Moon? The search for water had led to a new and critical re-evaluation of the old Viking data. A new hypothesis emerged, based on a discovery made by the Phoenix lander in 2008. Phoenix found that the Martian soil contains perchlorates, a type of highly oxidizing salt. Scientists realized this could be the missing piece of the puzzle. When the Viking GCMS instrument had heated the Martian soil samples to search for organics, that very act of heating in the presence of perchlorates could have been catastrophic. The combination would have instantly incinerated any organic molecules that were present, breaking them down into simple gases like carbon dioxide, which the instrument was not designed to interpret as a sign of complex organics. This possibility was deeply ironic. The instrument that provided the definitive no organics result, the result that led the scientific community to dismiss the possibility of life and abandon the search for decades, may have been the instrument that inadvertently destroyed the very evidence it was looking for. The successful quest to follow the water did not solve the mystery of Viking. Instead, it deepened it, suggesting that the initial conclusion of a dead planet was based not on a lack of life, but perhaps on a fundamental misunderstanding of our own tools in a truly alien environment. As rovers like Spirit, Opportunity, and Curiosity confirmed Mars's habitable past, another instrument aboard Curiosity began to scrutinize the planet's present-day environment. While its drills and cameras studied the rock record, a sophisticated suite of tools known as the Sample Analysis at Mars, or SAM, was tasked with sniffing the thin Martian atmosphere. Its purpose was to analyze the chemical composition of the air, and in doing so, It detected a chemical anomaly that has become one of the most compelling and frustrating Martian mysteries: the transient whispers of methane. The discovery was gradual. Curiosity's tunable laser spectrometer, a key component of the SAM instrument, found that Mars has a very low background level of methane in its atmosphere, just a faint trace. But then it recorded something unexpected. On several occasions, the concentration of methane in the air directly around the rover would suddenly spike, increasing by a factor of 10 or more. These plumes of methane were not a constant feature. They would appear, last for a period of weeks or months, and then vanish, returning the local atmosphere to its normal background level. Even more intriguingly, these spikes appeared to have a seasonal pattern, tending to occur during the warmer summer months in Gale Crater. This was a significant finding because on Earth, methane is a powerful biosignature. Over 90% of the methane in our planet's atmosphere is produced by biological processes, from microbes in wetlands to the digestive systems of livestock. The detection of methane on Mars, especially in transient, seasonal plumes, immediately opened the door to the possibility of modern-day biological activity. The hypothesis is that communities of subsurface microbes or methanogens could be living underground, shielded from the harsh surface radiation. During warmer seasons, changes in temperature or pressure might allow them to become more active, releasing bursts of methane gas that then seep up through cracks and fissures in the rock to be detected by the rover. However, there is a competing explanation. Methane can also be produced through purely geological processes. A reaction known as serpentinization, which involves the interaction of water with certain minerals like olivine deep underground, can generate methane without any need for life. This non-biological theory suggests that ancient methane, trapped in subsurface reservoirs for millions of years, could be periodically released through fractures in the crust. Yet, this geological model struggles to fully explain the data. Geological seepage is typically expected to be slow and steady, or linked to major seismic events. It is difficult to account for the sharp, temporary, and seasonally patterned spikes that Curiosity has observed. The behavior of the gas seems more dynamic than what a slow geological process would suggest. This debate between a biological and geological origin created a compelling puzzle, but the mystery deepened significantly with data from another spacecraft. While Curiosity was making its ground-based measurements, the European Space Agency's Trace Gas Orbiter, TGO, arrived at Mars. Its primary mission was to create a highly detailed global map of trace gases in the Martian atmosphere, with instruments far more sensitive than Curiosity's for detecting methane over wide areas. The scientific community expected TGO to pinpoint the sources of Curiosity's methane plumes, perhaps identifying specific regions where the gas was seeping out. The results from TGO were baffling. The orbiter found almost no methane at all. Its high-precision instruments have consistently failed to detect the gas anywhere in the Martian atmosphere, even when flying directly over Gale Crater at the same time Curiosity was reporting a spike on the ground. This created a direct contradiction. How can a reliable rover on the surface be detecting methane plumes, while an even more sensitive orbiter in the sky sees nothing? This inconsistency between the ground and orbital data is now the central part of the methane mystery. The leading hypothesis to resolve this conflict is that there might be an unknown and highly efficient destruction mechanism in the lower Martian atmosphere. This process would have to be capable of breaking down methane molecules almost as soon as they seep from the ground, preventing the gas from ever accumulating in sufficient quantities to be detected by the orbiter. What this mechanism could be is completely unknown. For now, the methane on Mars remains an unexplained animalia gas strongly associated with life, appearing in patterns that are difficult to explain with geology, confirmed by ground-based measurements, but entirely invisible from space. The history of Mars exploration is a story of learning from ambiguity. The Viking landers of the 1970s returned a tantalizing biological signal that was ultimately dismissed due to a conflicting chemical result, creating a scientific schism that has never fully healed. Decades later, the Curiosity rover detected plumes of methane, a potential biosignature. But these signals were inconsistent, appearing for the rover on the ground but remaining invisible to more sensitive instruments in orbit. These missions, for all their groundbreaking discoveries, taught a hard and humbling lesson. Searching for definitive evidence of life on the surface of another world is an endeavor fraught with uncertainty. The Martian environment is profoundly alien, with a complex and exotic chemistry that can mimic biology, and a harsh radiation climate that actively works to erase the very evidence being sought. A direct, unambiguous yes or no from a robotic instrument operating alone, millions of miles from Earth, seemed perpetually out of reach. This legacy of scientific frustration and hard-won experience directly shaped the mission of the Perseverance rover, which landed in Mars's Jezero crater in February 2021. This mission was not conceived to merely repeat the experiments of the past with slightly better tools. It was designed to fundamentally change the entire strategy of the search. Perseverance represents a profound philosophical shift, an acknowledgement that the answers to questions of this magnitude may not be found through remote analysis alone. It is the first indispensable step in a new, patient, and audacious multi-decade plan. Its core mission is not to find life itself, but to identify and collect the most promising evidence of ancient life, and prepare it for a return journey to Earth. The central problem that Perseverance was designed to solve is the inherent unreliability of in situ, or on-site, detection. The Viking missions illustrated this perfectly. The labeled release experiment looked for an activity metabolism HILE. The gas chromatograph mass spectrometer looked for a body organic molecules. When one instrument gave a positive signal and the other gave a negative, the result was not clarity, but an intellectual cul-de-sac that has generated debate for nearly 50 years. Experience has shown that Mars is exceptionally good at creating such riddles. Furthermore, the Martian surface is an incredibly hostile place for the chemical building blocks of life. For billions of years, it has been subjected to an unrelenting bombardment of intense ultraviolet radiation from the Sun and high-energy galactic cosmic rays from deep space, unprotected by a thick atmosphere or a global magnetic field. This radiation is not passive. It is a powerful destructive force, aggressively breaking the chemical bonds of complex organic molecules and degrading them into simpler, less interesting compounds. On top of this, the very soil is chemically reactive. The discovery of perchlorate salts in the Martian regolith by the Phoenix lander in 2008 provided a plausible and deeply ironic explanation for why Viking's GCMS found no organics. The instrument worked by heating soil samples to vaporize any organic compounds for analysis. It is now understood that heating a soil sample containing both perchlorates and organic molecules would likely trigger a powerful chemical reaction, instantly incinerating the organics. The very method used to liberate the evidence for detection was likely the method that destroyed it. Searching for pristine organic molecules or living microbes on the surface of Mars is therefore like trying to find a perfectly preserved ancient manuscript in a field that has been alternately soaked in acid and set on fire for eons. The chances of a clear, unambiguous find are vanishingly small. This realization demanded a shift in strategy, away from the hunt for fragile, active life and towards the search for durable, fossilized evidence of its past. This new strategy centers on the search for biosignatures. A biosignature is not life itself, but a preserved sign of its existence, a physical object, a chemical pattern, or a mineralogical texture that requires a biological origin to explain. It is the scientific equivalent of finding a fossilized footprint instead of a living dinosaur. The Perseverance rover was dispatched to Jezero crater for this very purpose. The location was chosen after a years-long selection process because orbital imagery revealed it to be a near-perfect geological setting for preserving such evidence. Billions of years ago, Jezero was the site of a deep, calm lake, fed by a powerful river that carved a channel through the crater rim and deposited sediment in a classic fan-shaped delta. Such environments are ideal for trapping and fossilizing organic material and microbial life. Perseverance is equipped with a sophisticated suite of instruments to identify several types of potential biosignatures. One of the most sought-after forms is microfossils, preserved physical shapes of ancient microbial cells. While microscopic, the structures of microorganisms can become fossilized in fine-grained sedimentary rock, like the mudstone that settled at the bottom of the Jezero Lake. The rover's cameras and spectrometers can identify promising rock textures and mineralogies where such fossils might be preserved. A more macroscopic target is stromatolites. On Earth, these are layered mound-like rock structures, sometimes growing to several feet high, built by vast colonies of microbes in shallow water. As mats of microorganisms trap and bind sediment, they build up distinctive laminated layers over time, creating a structure that is very difficult to produce through purely geological means like wind or water deposition. Perseverance is meticulously scanning the ancient shoreline of the Jezero Lake Delta for these characteristic patterns. The rover is also hunting for chemical biosignatures. While simple organic molecules can be created through non-biological processes, life tends to produce uniquely complex and specific compounds. Certain types of lipids fatty molecules that form cell membranes can be very durable and serve as molecular fossils. The rover's Sherlock and PIXL instruments work in tandem to map the distribution of organics and minerals in a rock at a near microscopic scale. They search for concentrations of complex molecules that would signal a biological origin, looking not in the exposed irradiated surface soil, but by drilling into the interior of rocks where these chemicals might have been protected for billions of years. However, even with its advanced instruments, Perseverance's primary mission is not to make a definitive confirmation of life on its own. The lessons of Viking were well learned. A rover's analysis, however sophisticated, can still be ambiguous. The ultimate goal of Perseverance is to act as a brilliant geological scout, using its instruments to identify the most scientifically compelling rocks and collecting them for the final decisive step in the search for life. The Mars Sample Return Campaign. The solution to the problem of ambiguity is to bring the best Earth-based laboratories to bear on Martian samples. The Perseverance rover is the first leg of this extraordinary relay race across the solar system. Its most critical function is its complex sample caching system, an engineering marvel designed to collect and hermetically seal pristine rock samples. When a promising rock is identified, the rover uses a rotary percussive drill on its robotic arm to extract a coarse sample about the size of a piece of chalk. This sample is then passed inside the rover's body, where a 7-foot robotic arm measures, photographs, and seals it inside a sterile hyperclean titanium tube. The cleanliness of this process is paramount. Each tube was rigorously sterilized before launch to ensure that the rover does not contaminate Mars with terrestrial microbes, and more importantly, to guarantee that when these samples are eventually analyzed, scientists can be certain that any organic material found is genuinely Martian. Once sealed, the rover can either store the tube in its chassis or drop it on the surface at a pre-planned location, creating a sample depot. This depot, such as the one named Three Forks, acts as a collection point, a message in a bottle left on the Martian surface as a backup for a future mission to retrieve. This future mission is the multi-part Mars Sample Return (MSR) campaign. The current plan involves sending a second lander, the Sample Retrieval Lander (SRL), to Mars. This lander will carry a small, agile fetch rover and a small rocket called the Mars Ascent Vehicle (MAV). The fetch rover will travel to the depot, systematically pick up the sample tubes left by Perseverance, and return them to the lander. The tubes will then be loaded by a robotic arm into a container at the top of the MAV. In what will be a historic first in the annals of space exploration, this rocket will launch from the surface of another planet, carrying its precious cargo into Mars orbit. Waiting in orbit will be a third spacecraft, the Earth Return Orbiter (ERO), built by the European Space Agency. It will perform a complex, fully autonomous rendezvous and capture the basketball-sized container holding the samples. This maneuver, tracking and catching a small object moving at thousands of miles per hour, is an immense technical challenge. Once the container is secured inside a sterile containment system, the orbiter will fire its engines and begin the long, multi-month journey back to Earth. Upon its arrival, it will release the sample container, which will enter the atmosphere and make a soft landing at a secure, designated site. This elaborate and ambitious plan is the only currently conceived way to achieve a definitive answer. No instrument that can be miniaturized and sent to Mars can match the analytical power of the full-scale laboratories on Earth. With return samples, scientists will be able to use instruments the size of a room synchrotron particle accelerators, high-resolution electron microscopes, and multiple types of mass spectrometers to examine the rocks at an atomic level. They can meticulously search for microfossils, analyze isotopic ratios that hint at metabolic processes, and identify specific organic compounds with a level of certainty a rover could never achieve. Crucially, multiple independent teams in labs around the world can analyze the samples, cross-checking results and building a global scientific consensus. If evidence of life is found, it will have been verified by the most powerful tools and the most rigorous scrutiny humanity can offer, finally putting an end to the ambiguities that have haunted the search for life on Mars. Perseverance, therefore, represents a profound shift in thinking. It is an admission that the most important questions require patience and collaboration on a global scale. Its mission is not to provide an instant answer, but to perform the indispensable first step of a longer, more deliberate process. Its ultimate success is not measured by a single data point from its own instruments, but by the collection of scientifically rich samples now sitting sealed in their titanium tubes on the dusty floor of Jezero crater. The final answer to the question of Martian life is no longer being sought in faint, ambiguous signals from a distant world. It is waiting to be physically brought home. The samples collected by Perseverance now sit on the Martian surface, waiting for a ride home. The final answer to the question of Martian life may already be sealed inside those tubes, hidden from our view for now. In 1947, a decorated American admiral led a massive naval fleet to Antarctica, only to retreat under mysterious circumstances. His private diary later allegedly described a hidden world beyond the pole. This event became a cornerstone of the Hollow Earth legend. Of all the persistent legends that challenge our modern understanding of the world, few are as grand or as enduring as the theory of the Hollow Earth. It is the belief that our planet is not a solid sphere of rock and metal, but a hollow shell, containing within it a secret interior world, perhaps warmed by a central sun and accessible through vast openings at the North and South poles. In the 21st century, this idea is relegated to the realm of fiction and fringe belief, a concept so at odds with established geology that it seems almost absurd. But the theory did not begin as a wild fantasy. Its origins are rooted in the age of scientific revolution, born from the mind of one of history's most respected astronomers as a serious attempt to explain a genuine scientific puzzle. This is the story of how the Hollow Earth theory evolved from a rational, if incorrect, scientific postulate into a powerful and popular myth that would capture the public imagination for centuries. The story begins in the late 17th century, a time of immense intellectual ferment in Europe. The scientific method was taking hold, and the greatest minds of the age were grappling with the fundamental laws of the universe. Isaac Newton had just published his Principia Mathematica, laying out the laws of motion and universal gravitation. It was a time when the cosmos seemed to be yielding its secrets to the power of human reason and observation. In this environment of discovery worked Edmund Halley, an English astronomer, geophysicist, and mathematician of extraordinary talent and breadth. Today, his name is inextricably linked with the famous comet whose return he successfully predicted, a triumph of Newtonian physics. But Halley's scientific curiosity was not limited to the heavens. It extended deep into the Earth itself. He was wrestling with the perplexing problem: the strange and unpredictable behavior of the magnetic compass. Mariners had long known that the compass needle did not point to the true geographic North Pole, but to a separate magnetic pole. More confusingly, this magnetic pole was not fixed. Over time, its position slowly drifted, a phenomenon known as secular variation. Navigators had to constantly update their charts to account for this drift, but no one understood its cause. What force could be powerful enough to make the planet's entire magnetic field wander? In 1692, Halley presented a radical hypothesis to the Royal Society of London. He proposed that the Earth was not a single solid sphere. Instead, he theorized that it was composed of a series of concentric, nested shells, one inside the other like a Russian doll, all rotating at slightly different speeds around a central core. Each of these shells, he suggested, could have its own magnetic field. The slow differential rotation between these internal spheres would cause their combined magnetic influence to shift over time, neatly explaining the observed drift of the compass needle on the surface. It was an elegant and ingenious solution to a real scientific problem, using the available data. But Halley did not stop there. His rational mind took the idea to its logical and most spectacular conclusion. If these shells existed, what was the nature of the space between them? He proposed that these inner surfaces could be habitable. He even suggested that the space could be filled with a luminous atmosphere, providing light and warmth to potential inhabitants of these interior worlds. To Halley, this was not a matter of idle fantasy. It was a reflection of divine providence. He found it difficult to believe that a benevolent creator would leave such vast spaces within the planet empty and useless. He wrote that the interior of the Earth was likely populated with life and inhabited by beings whose natures are suitable to their respective places. For Halley, the hollow Earth was not a myth, but a reasoned extrapolation of physical evidence, a theory that explained a known anomaly, while also satisfying a philosophical belief in a purposeful universe. His ideas, published by the most prestigious scientific body in the world, gave the concept an air of legitimacy that would last for over a century. For the next 100 years, Halley's theory remained a subject of learned speculation. Other thinkers, such as the Swiss mathematician Leonhard Euler, toyed with similar ideas, sometimes proposing a hollow Earth with a central sun to illuminate the interior. But it remained largely within the confines of scientific and philosophical debate. It took a most unlikely figure, an American war veteran and grocery supplier with no formal scientific training, to wrench the theory from the pages of academic journals and launch it into the public consciousness as a passionate, all-consuming crusade. That man was John Clevis Sims, Jr., a former U.S. Army captain from Ohio. Sims became obsessed with the idea of a hollow Earth in the early 1800s. He developed his own more detailed version of the theory. He believed the Earth was a hollow shell approximately 800 miles thick, containing several more concentric shells. Most importantly, he declared that there were massive openings at both the North and South poles, which he called Sims holes, each thousands of miles in diameter. The rims of these holes, he argued, were curved in such a way that a traveler could sail directly over the edge and into the interior without even realizing they had left the outer surface. He envisioned an inner world, warmed and lit by the sun's rays reflecting off the inner concave surface, a verdant and habitable landscape waiting to be explored. In 1818, Sims embarked on a mission to prove his theory. He printed thousands of copies of a circular and sent them to universities, scientific societies, and prominent individuals across the United States and Europe. The circular, boldly titled Circular Number 1, began with the declaration, "To all the world, I declare the earth is hollow and habitable within." He proclaimed his devotion to the theory, pledging his life to its exploration and stating his belief that he was seeking not just fame, but the discovery of new, rich, and populous countries. Sims's campaign was relentless and all-encompassing. He was not a quiet scholar. He was a public evangelist. He traveled across the country, delivering impassioned lectures in towns and cities, using a large hollow wooden globe with the polar sections removed to demonstrate his ideas. His talks were popular spectacles. While the scientific establishment largely dismissed him as a crank, the general public was captivated. In an era of great exploration, when Lewis and Clark had only recently charted the American West, the idea of an entirely new world to discover held immense appeal. Sims became a minor celebrity, a figure of both fascination and ridicule, often referred to as a Newton of the West. His ultimate goal was not just to persuade but to act. He believed so fervently in his theory that he dedicated years of his life to petitioning the United States Congress to fund a naval expedition to the North Pole to find the opening and sail into the Earth's interior. He submitted formal proposals, backed by petitions signed by his supporters. He argued that the expedition would bring immense glory, scientific knowledge, and commercial advantage to the nation. While his proposals were repeatedly debated in Congress, they were always ultimately rejected, often by a wide margin. The political and scientific establishments were not willing to stake national resources on what they considered a delusion. One of Sims's most dedicated followers was a journalist named Jeremiah N. Reynolds. Reynolds was initially skeptical but became a convert after meeting Sims. Possessing the political and rhetorical skills that Sims lacked, Reynolds became the chief promoter of the cause. He lobbied politicians in Washington, D.C., wrote articles, and gave lectures that were more polished and persuasive than Sims's. Even after Sims's death in 1829, Reynolds continued the campaign. Though he eventually abandoned the specific hollow Earth aspect of the quest, his relentless lobbying was a key factor in the eventual launch of the United States Exploring Expedition of 1838 to 1842. This expedition, also known as the Wilkes Expedition, would go on to explore a vast portion of the Pacific Ocean and confirm the existence of Antarctica as a continent. Ironically, the real-world exploration that Sims's movement helped inspire would ultimately contribute to the scientific evidence that disproved his theory. Sims died a disappointed man, his dream of a polar expedition unrealized. His legacy was a monument erected by his son, a stone representation of a hollow globe, a testament to a failed scientific crusade. Though Sims's campaign failed to convince the scientific community, it succeeded spectacularly in another arena: the human imagination. He had taken an abstract scientific idea and turned it into a powerful and romantic narrative of adventure and discovery. The concept of the hollow Earth, with its polar openings and hidden inner worlds, proved to be irresistible source material for writers and storytellers. The theory's scientific death gave birth to its new life as a potent literary myth. The transition was immediate. Reynolds himself, after his association with Sims, wrote a fictional article in 1836 titled A Reprimand for an Accomplished Finish, which described a journey into a hollow planet. But the most significant influence was on one of America's greatest writers, Edgar Allan Poe. In 1838, Poe published his only full-length novel, The Narrative of Arthur Gordon Pym of Nantucket. The novel is a harrowing tale of shipwreck and mutiny that culminates in the narrator's boat being swept by a powerful current toward the South Pole. In the final cryptic scene, a chasm opens in the ice, and a giant, shrouded white figure emerges as the boat is pulled into the abyss. The imagery drew heavily on the ideas of Sims and Reynolds, cementing the connection between the Antarctic and a mysterious, otherworldly entrance. The concept truly went global with the work of the French author Jules Verne, the father of science fiction. In 1864, he published A Journey to the Center of the Earth. While Verne's story did not feature a completely hollow planet or polar openings, it was a direct product of the intellectual climate that the hollow Earth theory had created. His protagonists enter the Earth's interior through an extinct volcano in Iceland and discover a vast, subterranean world complete with its own sea, prehistoric creatures, and a strange source of illumination. Verne's novel was an international bestseller, translating the abstract theory into a vivid, thrilling adventure that became a permanent part of popular culture. He took the what-if of the theory and gave it flesh, bone, and spectacle. By the end of the 19th century, the transformation was complete. What had begun as Edmund Halley's serious, data-driven attempt to explain magnetic variation had been transformed, first by the passionate, misguided crusade of John Clevis Sims, and then by the creative power of literary giants like Poe and Verne. The hollow Earth was no longer a subject for the Royal Society. It was a fixture of adventure stories, a place of mystery and wonder existing just beyond the known boundaries of the world. The scientific hypothesis had died, but the myth had become immortal. This myth would lie dormant for a time, waiting for the anxieties and legends of the 20th century to give it new life, attaching it to the last unexplored continent on Earth, Antarctica. The myth of a hollow Earth, born from the scientific inquiries of the 17th century and popularized by the Crusades of the 19th, needed a physical location to anchor itself in the modern world. As the continents were mapped and the globe's mysteries receded, only one place remained sufficiently vast, unknown, and forbidding to house such a profound secret: Antarctica. The frozen continent at the bottom of the world became the final frontier not just for explorers, but for the human imagination. In the 20th century, two powerful and historically distinct narratives would converge upon this icy landscape. The first was a legend of a secret Nazi redoubt, a last bastion of a defeated ideology hidden beneath the ice. The second was the story of the largest military expedition ever to visit Antarctica, an American naval fleet led by a national hero that allegedly encountered a technologically superior force and was forced into a mysterious retreat. The intertwining of these two stories, the Nazi legend and the enigma of Operation Highjump, would cement Antarctica's place in modern mythology as the gateway to a hidden world. To understand the legend, one must first understand the man at its center: Admiral Richard E. Byrd. By the mid-1940s, Byrd was a global icon, the embodiment of American courage and exploratory spirit. A decorated naval officer and pioneering aviator, he was celebrated for his flights over both the North and South Poles, and had led previous expeditions to the Antarctic. He was a trusted, credible, and heroic figure, which made the events of his final largest expedition all the more susceptible to speculation. When he was chosen to lead Operation Highjump in 1946, it was seen as a fitting command for America's foremost polar explorer. On the surface, Operation Highjump was a clear demonstration of American post-war power and ambition. The world was entering the dawn of the Cold War, and the strategic importance of polar regions for weather forecasting, potential air routes, and resource claims was becoming increasingly apparent. The official objectives of the mission were pragmatic and multifaceted. The primary stated goal was to train naval personnel and test military equipment in extreme cold weather conditions. The U.S. Navy needed to know if its ships, aircraft, and men could function effectively in the brutal Antarctic environment, a clear preparation for potential conflict with the Soviet Union in Arctic regions. A secondary goal was to establish a permanent American research base, Little America 4, solidifying the United States' long-standing, though unofficial, claims to a significant portion of the continent. Finally, the mission had a vast scientific component, principally to conduct an extensive aerial survey to photograph and map as much of the coastline and interior as possible. The scale of the operation, however, far exceeded that of any previous scientific or exploratory venture. It was, for all intents and purposes, a military task force. The fleet, which departed from U.S. naval bases in late 1946, consisted of over 4,700 men, 13 ships including an aircraft carrier, the USS Philippine Sea, destroyers, tankers, and icebreakers, and dozens of aircraft. The deployment of an aircraft carrier to Antarctica was unprecedented. To the public, it was presented as a grand national enterprise, a testament to American ingenuity. To many observers today, this overwhelming military might seem disproportionate for a mission to test winter clothing and map coastlines, providing the first kernel of suspicion upon which the subsequent legend would be built. Despite its military composition, the initial phase of Operation Highjump proceeded largely according to plan. The fleet successfully navigated the treacherous pack ice. The base at Little America 4 was established. Byrd himself arrived dramatically aboard a transport plane and conducted several high-profile flights, including another flight over the South Pole. The photographic planes, launching from both the carrier and land-based runways, successfully mapped hundreds of thousands of square miles of previously unknown territory. For a few weeks, the mission was a resounding success, a triumph of logistics and determination chronicled in newsreels back home. Then the narrative shifts. The mission, which was planned to last between 6 and 8 months, came to a sudden and premature end. In late February 1947, after only about 8 weeks on the continent, the main naval group, the Central Group, was unexpectedly ordered to withdraw from Antarctica and return to the United States. The official explanation was that the early onset of the Antarctic winter and worsening ice conditions made continued operations too dangerous. On paper, this was a plausible reason. The Antarctic environment is unforgiving, and the safety of thousands of men and a fleet of valuable ships would have been a primary concern. However, it is this abrupt end that forms the foundation of the mystery. The speed of the withdrawal, combined with the series of strange events, fueled rumors that the official story was a cover for something far more dramatic. The first public hint that something was amiss came from an interview Admiral Byrd allegedly gave to Lee Van Atta, a correspondent for the Chilean newspaper El Mercurio, in Santiago, Chile, on his journey home. In the article, published on March 5, 1947, Byrd is quoted as warning of a new threat to the United States. He allegedly spoke of the necessity for America to prepare to defend itself against enemy fighters that can fly from pole to pole at incredible speeds. This single, startling quote, attributed to a sober national hero, was an explosive claim. Flying objects that could transit between the poles at fantastic velocity sounded nothing like any known Soviet technology of the era. This report was later amplified by the emergence of what is claimed to be Admiral Byrd's secret diary. It is crucial to note that the authenticity of this diary is highly disputed, with most historians considering it a later fabrication. It did not surface until decades after Byrd's death. Yet, its contents provide the core narrative for the Hollow Earth connection. In the purported diary, Byrd describes a flight on February 19, 1947, where he flew beyond the pole into a vast, hidden territory. He describes his instruments going haywire as he flies over mountain ranges into a lush, green valley with rivers and strange, mammoth-like animals. He claims to have been escorted by saucer-shaped flying craft, which he calls flugelrads, that lead him to a landing in a shimmering city. There he meets a figure known as the master of a civilization called Agartha, the inhabitants of the inner world. This master warns Byrd that the surface world's use of nuclear weapons is a threat to them all, and that they had sent their flying craft to investigate after the bombings of Hiroshima and Nagasaki. Byrd is then tasked with delivering this warning to the powers of his world, before being guided back to his base. According to the legend, this astonishing encounter was the real reason for the mission's failure. Proponents claim Operation Highjump was not just a training exercise, but a military force sent to confront a hostile power in Antarctica, and it was decisively defeated. The rumors speak of heavy casualties, far beyond the 3 men officially known to have died in the crash of a PBM Mariner aircraft. They tell of destroyed aircraft, damaged ships, and a panicked retreat in the face of a technology against which the U.S. Navy was helpless. The pole-to-pole flying objects mentioned in the El Mercurio article were, in this context, the flying saucers from the inner world. This narrative of a secret war in Antarctica might have remained a standalone piece of UFO lore had it not merged with another, darker legend born from the ashes of World War II, the myth of a secret Nazi base. To understand this connection, one must go back to 1938. As the Third Reich was consolidating its power, it launched the German Antarctic expedition. A vessel, the MS Schwabenland, equipped with 2 seaplanes, traveled to a sector of Antarctica south of the Atlantic. The planes conducted a massive aerial survey, photographing a vast territory which the Germans named New Schwabenland, New Swabia, and claimed for the Reich by dropping thousands of metal darts bearing the swastika. The official purpose of the expedition was economic, to find a location for a German whaling station to secure a domestic source of industrial fats and oils, thus reducing Germany's reliance on foreign imports. It was a brief, single expedition, and no permanent base was ever established. But after the war, this historical footnote mutated into a powerful conspiracy theory. The legend asserted that the 1938 expedition was a cover. Its real purpose was to establish a top-secret, heavily fortified base known as Base 211. This base was said to be located in a remarkable ice-free oasis, a system of caves and tunnels warmed by geothermal heat deep within the mountains of New Swabia. This hidden sanctuary, the story goes, was to be the last redoubt for the Nazi leadership. After the fall of Berlin, leading Nazis, possibly even Hitler himself, were said to have escaped via U-boat to Base 211 to continue their work on Wunderwaffen, wonder weapons. Most significantly, these wonder weapons were identified with the advanced, saucer-shaped aircraft that witnesses began reporting in the late 1940s. The legend claims that Nazi scientists, perhaps with occult or extraterrestrial help, had developed highly advanced anti-gravity flying discs, known in the lore by names like Haunebu or Vril. This is where the Nazi legend makes its critical link to the older Hollow Earth theory. Base 211 was not merely a hideout on the continent, it was the entrance. The Nazis, the theory posits, had discovered the polar opening and made contact with the inhabitants of the inner world, or had established their own domain within the Earth's shell. The synthesis of these narratives created the modern, fully formed legend. The story now went like this. The United States government, having learned of the secret Nazi stronghold in New Swabia through captured German intelligence, realized the immense threat posed by this remnant of the Third Reich and its superweapons. Operation High Jump was therefore not a scientific mission, but a covert military invasion, a full-scale assault designed to locate and destroy Base 211. Admiral Byrd's massive fleet was sent to lay siege to the Nazi fortress. However, they were met not by soldiers in snow gear, but by a fleet of superior Nazi flying saucers emerging from the ice. The American forces were outmatched, suffering heavy losses in a secret battle that has been erased from history. A defeated and humbled Byrd was forced to retreat. His cryptic interview in Chile and his secret diary were his desperate, coded attempts to warn the world of the terrible power he had encountered at the bottom of the world, a power that originated with the Nazis and was connected to the world beneath the ice. This grand unified theory provides a compelling, internally consistent explanation for all the disparate, mysterious elements. The oversized military nature of High Jump, its abrupt and unexplained termination, Byrd's strange alleged statements, and the historical reality of Germany's pre-war interest in Antarctica. It weaves documented history with rumor, speculation, and outright fiction into a seamless and thrilling tapestry. While there is no credible, verifiable evidence to support the existence of Base 211, a secret battle, or the authenticity of Byrd's diary, the power of the narrative is undeniable. It transformed Antarctica from a desolate wasteland into a stage for a secret war, and it repurposed the Hollow Earth from a quaint 19th-century theory into a modern conspiracy of terrifying geopolitical significance. The gateway to the inner world was now guarded by the ghosts of the Third Reich. In stark contrast to the dramatic and clandestine world portrayed in the Hollow Earth legend, the scientific understanding of our planet and the continent of Antarctica presents a narrative that is, in its own way, just as awe-inspiring. This narrative is not built on secret diaries or rumored battles, but on decades of painstaking data collection, meticulous analysis, and the collaborative effort of thousands of scientists around the world. Through a variety of sophisticated techniques, science has peeled back the layers of the Earth, from its fiery core to its frozen poles, revealing a world that is solid, dynamic, and ancient. While this scientific reality definitively refutes the notion of a hollow planet with polar openings, it has also unveiled its own hidden world beneath the Antarctic icy landscape of buried mountains and isolated lakes that is nearly as alien and mysterious as any fictional inner realm. The most fundamental and comprehensive evidence against a hollow Earth comes from the field of seismology, the study of earthquakes and the propagation of seismic waves through the planet. For over a century, scientists have been using a global network of seismographs to record the vibrations generated by earthquakes. These waves, which travel outward from an earthquake's epicenter, are not uniform. They behave differently as they pass through materials of varying density, temperature, and states, solid, liquid, or gas. By analyzing the travel times, reflections, and refractions of these waves as they arrive at different stations around the globe, scientists can construct a detailed, three-dimensional model of the Earth's interior process known as seismic tomography. It is, in effect, a planetary-scale ultrasound. This seismic picture of Earth is clear and unambiguous. It reveals a layered structure that is entirely inconsistent with the hollow Earth model. At the very center lies the inner core, a solid sphere of primarily iron and nickel alloy, roughly the size of the Moon, with temperatures as hot as the surface of the Sun. The immense pressure at the center, over 3.6 million times that of the surface atmosphere, is so great that it forces the iron to remain solid despite the extreme heat. Surrounding this is the outer core, a 1,400-mile thick layer of liquid iron and nickel. It is the convective motion within this churning, liquid metal ocean that generates Earth's global magnetic field, providing a complete and evidence-based explanation for the phenomenon that first puzzled Edmund Halley. The theory of nested shells is not needed. The geodynamo of the liquid outer core accounts for the magnetic field and its secular variation. Above the core lies the mantle, a massive layer of hot, dense silicate rock approximately 1,800 miles thick. While it is technically solid, the mantle behaves like a very viscous fluid over geological timescales, with slow-moving convection currents that drive the movement of tectonic plates on the surface. Finally, we live on the crust, a thin, brittle outer layer that is, on average, only about 20 miles thick under the continents and even thinner under the oceans. Seismic data has mapped these layers in exquisite detail. The waves slow down as they hit the liquid outer core, creating a shadow zone on the other side of the planet where direct waves are not detected. They reflect off the boundaries between layers and speed up or slow down based on density. Nowhere in this vast collection of global data is there any evidence of massive voids, concentric shells, or a central cavity. Any hollow space on the scale imagined by the theory would cause seismic waves to stop, reflect, or diffract in ways that would be immediately and obvious to seismologists. The silence from the data is deafening. The Earth is solid. This conclusion is powerfully reinforced by another fundamental force of nature: gravity. The law of universal gravitation, first formulated by Isaac Newton, states that the gravitational force between two objects is proportional to their masses. We can measure the Earth's gravitational pull with extreme precision by observing its effect on objects both on its surface and in space. The orbit of the Moon, the paths of artificial satellites, and the downward acceleration of an object dropped at the surface are all direct functions of the Earth's total mass. From these measurements, scientists have calculated the mass of the Earth to be approximately 5.97 sextillion metric tons. Furthermore, we know the volume of the Earth from its measured diameter, When we divide the planet's mass by its volume, we arrive at its average density, which is about 5.5 grams per cubic centimeter. This density is significantly higher than that of the rocks we find on the surface, which typically have a density of around 2.7 grams per cubic centimeter. This discrepancy is a crucial piece of evidence. It tells us that the interior of the planet must be composed of something much denser than surface rock. This leads directly to the conclusion that the Earth has a heavy, metallic core of iron and nickel, perfectly aligning with the findings of seismology. A hollow Earth, by contrast, would have vastly less mass for the same volume. Its gravitational pull would be significantly weaker, and its average density would be much lower. Satellites would orbit differently, and our own weight on the surface would be less. The numbers simply do not add up. The planet's measured mass confirms that it is a solid, dense body. With the general structure of the planet firmly established, science has also turned its modern tools to Antarctica itself, the continent that serves as the legendary gateway. For much of human history, Antarctica was a true terra incognita, its interior hidden beneath an ice sheet 2 to 3 miles thick in places. What lay beneath this immense frozen shield was a complete mystery. The hollow Earth theory filled this void with a spectacular vision of a polar opening leading to a temperate inner world. The scientific reality uncovered over the past few decades is different, but in many ways no less dramatic. The primary tool for peering beneath the ice is ice-penetrating radar. This technique involves sending radio waves from an aircraft flying over the ice sheet. Some of the waves reflect off the surface, while others penetrate the ice and reflect off the boundary between the ice and the bedrock below. By measuring the time it takes for the waves to travel down and back, scientists can precisely map the thickness of the ice and, more importantly, the topography of the land hidden beneath it. This method has been used to create a comprehensive map of the subglacial continent. The results have been astonishing. Far from being a flat, uniform plain, the land beneath the Antarctic ice is a dynamic and complex continent in its own right. It contains vast basins, deep canyons, and colossal mountain ranges that rival any on the surface. The most spectacular of these is the Gamburtsev subglacial mountains, a range as large as the European Alps, with peaks rising to over 9,000 feet, all completely buried beneath thousands of feet of ice. The discovery of the Gamburtsevs was a major geological surprise, and their existence continues to puzzle scientists, who are working to understand how such a massive, young-looking mountain range could exist in the middle of an ancient continental craton. This is a real Antarctic mystery, but one of geology, not of a hidden civilization. Perhaps the most exciting discovery made beneath the ice is the existence of a vast, interconnected network of subglacial lakes and rivers. Over 400 of these liquid water bodies have been identified so far. The immense pressure from the overlying ice sheet lowers the melting point of water, while geothermal heat from the Earth's interior warms the base of the ice, allowing liquid water to exist in total darkness at temperatures below freezing. The largest and most famous of these is Lake Vostok, a freshwater lake roughly the size of Lake Ontario, buried under 2.5 miles of ice near Russia's Vostok Station. This lake has been sealed off from the surface world for at least 15 million years, creating a unique, pristine environment that has been isolated from the rest of the planet's biosphere for geological epochs. The discovery of these subglacial lakes has generated immense scientific excitement, primarily for its implications in the search for life in extreme environments. Scientists theorize that these dark, cold, high-pressure environments could harbor unique microbial ecosystems, life forms that have evolved in complete isolation, surviving on chemical energy from the underlying rocks rather than on sunlight. This has made the subglacial lakes of Antarctica a prime analog for searching for life on other worlds, such as the ice-covered oceans of Jupiter's moon Europa or Saturn's moon Enceladus. Russian teams have successfully drilled into Lake Vostok, and analyzing the water samples for signs of life is an ongoing, painstaking process. This is the real hidden world of Antarctica. It is not a temperate paradise accessible through a polar hole, but a continent of rock buried under miles of ice, characterized by extreme cold, immense pressure, and total darkness. It is a world of towering, invisible mountains and ancient, isolated lakes of liquid water. This scientifically verified landscape provides a compelling and factual alternative to the Hollow Earth legend. It satisfies the human desire for a hidden, mysterious world beneath the ice, but does so with evidence and data. It shows that while the specific claims of the Hollow Earth theory are demonstrably false and disproven by the fundamental principles of physics and decades of direct observation, the idea that Antarctica hides a secret, unseen world is, in a very real sense, true. The truth, however, lies not in a hollow cavity, but in the complex, frozen, and scientifically fascinating reality of a subglacial continent. Even in the face of overwhelming scientific evidence that establishes Earth as a solid, dynamic planet, the Hollow Earth legend has demonstrated remarkable resilience. It has survived the rigors of scientific scrutiny and adapted to the modern age, finding new evidence in the artifacts of the space race and drawing strength from a deep-seated human desire for mystery and undiscovered frontiers. The persistence of this belief is a fascinating case study in how a powerful narrative can endure, not by confronting scientific fact, but by reinterpreting it, finding anomalies and weaving them into a pre-existing tapestry of belief. The final chapter in the legend's evolution involves supposed proof from orbit, and a deeper look into the psychological drivers that keep this myth alive long after it was scientifically disproven. The advent of the space age in the mid-20th century presented a new and seemingly insurmountable challenge to the Hollow Earth theory. If there were truly giant, thousand-mile-wide openings at the poles, surely they would be one of the first and most obvious features photographed by the new satellites circling the globe. For a time, it seemed that the all-seeing eye of orbital technology would finally put the theory to rest. Instead, in a remarkable twist, early satellite imagery provided what proponents of the legend considered to be the most powerful visual proof to date. Photographs that appeared to show a massive dark hole at the North Pole. The images in question came from the Environmental Science Services Administration (ESSA) program in the late 1960s. Satellites like ESSA-3 and ESSA-7 were among the first dedicated weather satellites, placed in a polar orbit that allowed them to photograph the entire surface of the Earth as the planet rotated beneath them. Their mission was to provide the first daily, global view of weather patterns. To create these composite images, data from multiple orbital passes was stitched together into a single mosaic. It was an artifact of this very process that created the anomaly. The satellites were in a near-polar orbit, meaning their path took them close to the poles but not directly over them. On each pass there was a small, circular area at the geographic pole that the satellite's camera could not see. Furthermore, for half of the year, the pole is tilted away from the sun, plunging it into the complete darkness of the polar night. When the computers on the ground assembled the daily photographic mosaic, they were faced with a problem. What to do with this area of missing data? The standard practice at the time was simply to fill the void with black. The result was a stunning image of the Earth from space, with swirling cloud patterns, continents, and oceans, but with the perfect black circular hole at the very top of the world. To a public unaccustomed to interpreting satellite data, and to believers actively looking for confirmation, these images were nothing short of a smoking gun. They appeared to be exactly what John Clevy's Sims had described more than a century earlier. Books and magazines catering to fringe theories published the ESSA photographs as irrefutable proof. Here, from the objective eye of a government satellite, was the polar opening, the gateway to the inner world, hidden in plain sight. The fact that the images came from an official government source only added to their perceived credibility, fueling ideas that a conspiracy was in place to hide the truth. Proponents argued that these were not data artifacts, but real images of a real hole, and that subsequent images that did not show the hole were being deliberately altered or withheld from the public. Of course, the technical explanation for the hole at the pole is straightforward and well documented by the very agencies that produce the images, like NASA and NOAA, the successor to ESSA. It was a simple artifact of a satellite's orbital inclination and the data stitching process. Modern satellites in different orbits with more advanced sensors and processing techniques can now image the poles completely and continuously. These high-resolution images show an unbroken, unremarkable cap of ice and snow. There is no hole. The proof offered by the ESSA images was nothing more than a technological ghost, a misinterpretation of a data void. Yet, for a dedicated believer, this explanation is often seen as part of the cover-up, a convenient excuse created by the establishment to dismiss inconvenient evidence. The image of the black circle at the pole remains a powerful and iconic piece of hollow Earth lore, recycled endlessly online as evidence for the theory. This pattern of finding and reinterpreting anomalies extends beyond satellite imagery. Proponents of the theory often point to other, more abstract scientific data as potential proof. For example, they might cite the fact that seismic waves from earthquakes are known to slow down when they reach the Earth's core, creating a shadow zone. While seismologists understand this as the effect of waves entering the liquid outer core, a believer might reinterpret this as evidence that the waves are traveling around a central void. Similarly, the aurorast northern and southern lights have been woven into the myth. While science explains them as the interaction of charged particles from the sun with the Earth's upper atmosphere and magnetic field, the legend suggests they are actually gases escaping from the interior world through the polar openings, illuminated by the central sun. In every case, the method is the same. An observed phenomenon, which has a well-established scientific explanation, is stripped of its context and repurposed as proof for the pre-existing belief. This demonstrates a key reason for the theory's persistence. It does not operate according to the principles of scientific inquiry, which seeks to build a theory that best fits all available evidence. Instead, it operates on a principle of confirmation bias, selectively choosing pieces of data that appear to support a conclusion that has already been reached, while dismissing or reinterpreting all contradictory evidence as flawed, incomplete, or part of a conspiracy. This reliance on conspiracy is perhaps the most critical element in the survival of the Hollow Earth legend in the modern era. In a world where science has provided a comprehensive and robust model of a solid Earth, the only way for the theory to remain viable is to posit that this entire model is a deliberate fabrication. The conspiracy narrative suggests that a powerful, secret cabal often identified as world governments, elite scientific bodies, or a shadow government is aware of the truth of the inner world and is actively suppressing it from the public. This suppression narrative serves several crucial functions for the belief system. First, it explains the overwhelming lack of official evidence. There are no government-funded expeditions to the inner Earth because they don't want us to know about it. Second, it explains the unified voice of the scientific community. All the world's geologists and geophysicists are not independent researchers reaching the same conclusion based on data. They are either witting participants in the conspiracy or dupes who have been fed false information. Third, it provides a powerful psychological defense for the believer. By framing the issue as a struggle between a small group of truth seekers and a vast, powerful conspiracy, the believer is cast in a heroic role. They are not simply mistaken. They are a courageous dissident fighting against deception. This transforms a scientific disagreement into a moral crusade, which is a far more compelling and emotionally satisfying position to hold. Beyond the specific evidence and conspiracy theories, the enduring appeal of the Hollow Earth legend is deeply rooted in human psychology. It taps into several powerful and ancient archetypes that resonate with our collective unconscious. The most fundamental of these is the archetype of the lost paradise, or the hidden world. Throughout human history, in virtually every culture, there are myths of a perfect secret land, a place untouched by the corruptions and hardships of the surface world, a Garden of Eden, a Shangri-La, and Avalon. The hollow Earth is the modern, technological incarnation of this myth. It offers the promise of an undiscovered frontier, a pristine world waiting to be explored. In an age where every corner of the globe has been mapped, photographed, and cataloged, the idea that there is still a vast, unknown realm is incredibly appealing. It re-enchants a world that can sometimes seem mundane and fully known. The theory also offers a profound sense of escape. It posits a sanctuary from the problems of our world: war, pollution, political strife, and social decay. The alleged inhabitants of the inner world, as described in texts like the purported Diary of Admiral Byrd, are often depicted as being highly advanced, wise, peaceful, and spiritually evolved. They represent a utopian ideal, a model for what humanity could be if it were not for its self-destructive tendencies. For individuals who feel alienated or disillusioned with modern society, the belief in this hidden world can provide a powerful source of hope and psychological comfort. It suggests that there is a better way of life, and perhaps even a place of refuge. Finally, the legend of the hollow Earth speaks to a fundamental human curiosity and a desire for wonder. The scientific explanation of the world, while elegant and powerful, can sometimes feel complex and abstract. The story of a hollow planet with a central sun, strange creatures, and advanced civilizations is a narrative that is simple, visual, and deeply romantic. It evokes the spirit of the great age of exploration and the adventure stories of Jules Verne. It appeals to the part of us that wants to believe in magic, mystery, and the possibility that the universe is far stranger and more wonderful than we can imagine. In the end, the survival of the hollow Earth legend is a testament to the power of a good story. While science has thoroughly and convincingly mapped our planet's solid interior and revealed the true nature of the world beneath the Antarctic ice, it has not managed to extinguish the myth. The legend persists not because of the strength of its evidence, which is non-existent, but because of the strength of its narrative appeal. It offers its followers a sense of secret knowledge, a heroic role in a grand conspiracy, and a connection to a world of profound mystery and wonder. The scientific account of a solid Earth is the truth of our physical reality, but the legend of a hollow Earth speaks to the enduring needs of the human psyche: the need for a frontier, for a sanctuary, and for a world that still holds the promise of the unknown. Science has mapped Earth's solid core and revealed a world of subglacial lakes beneath Antarctica's ice. Yet, the story of Admiral Byrd's alleged encounter endures, a reminder that some legends are more resilient than the scientific facts that seek to replace them. Thanks for exploring with Ancient Relics Keeper. Stay curious, question everything, and remember the truth is often buried deeper than we think.